Okay, happy whatever that is whenever you are watching this video. So happy morning, evening, afternoon, night, 2 a.m., 2:40 a.m., whatever it is. So in this is the welcome to the fourth lecture on lanthanides and actinides series. In this lecture, we'll be going through the separation of lanthanides. Now, as discussed before, lanthanides are strikingly similar to one another, and separation of one lanthanide from another is an exceedingly difficult task. Very, very difficult. If I have to borrow words from some standard textbook, it has been written that the separation of lanthanides is as difficult as separation of one isotope from another. So that is a level to which the challenge we have. Now, in general, what are certain ways to separate atoms or ions? What characteristics do we exploit? So, first of all, we separate them if they can be differentiated. The word used here is differentiated. If they can be differentiated based on one charge, okay, second size, third, on the basis of the chemical properties, basicity, fourth, solubility, fifth, stability. No, these are the different ways in which we can exploit these yardsticks or these parameters to separate the lanthanides from one another. Now the thing about, can we separate lanthanides based on the charge? Now this is not possible, and it is not possible because of a simple reason that most of the lanthanides are +3 in oxidation state. So which means you do not get a differentiating factor here. So this is not possible, right? So we'll go through these things and try to see how we can differentiate, how we can separate lanthanides. The first is separation of lanthanides based on precipitation. Lanthanides based on precipitation. Precipitation or solubility. Okay, so I have a simple question for you. Now, what is a bond present between Na plus and Cl minus? You all know that it's ionic bond, no secret, ionic bond. Okay, what is a bond between CH covalent bond? Now, can a bond be, my question here is, can a bond be purely ionic or purely covalent? No, no bond is purely covalent or ionic. Every bond is partially ionic, partially covalent. So take few seconds and tell me which concept in general chemistry talks about this particular facet. If you remember, there is a concept called as 12th class, obviously, Fajan's rule. Fajan's rule tells that ionic bond can have partial covalent nature. Okay, so now, so what does it mean? Can we just go through this concept? Now you have an anion. What is an anion? If you are still confused, there is a mnemonic to remember: a negatively charged ion is anion. So anion has got the electron cloud. Now from your everyday experience, cloud, when we tell, does it have a definite shape? No, right? So it's got no definite shape. It's no definite shape. So if it's not got, if it has not got a definite shape, it can get deformed. Get deformed, right? Huh. So the ability of a anion to have its electronic cloud to get deformed is called as polarizability. Okay, so what do you mean by polar? What is happening? Polar का मतलब क्या हुआ? See, polar simply means we use it in even in a common everyday language, right? We are poles apart, or our ideas are poles apart or something. Which means it's contrasting. It's clearly a different stance. So North Pole, South Pole, all that. Okay, so the ability of an anion to have its electron cloud get deformed is called polarizability. Now, why does it get polarized? Why? What is it that makes an electron cloud to deform? This depends upon our 8th class simple funda. Like charges repel and unlike charges attract. Okay, so here you have a positively charged cation. Suppose you have a positively charged cation. What will happen is this electron cloud will can get deformed. So which means as electron cloud gets deformed, what was your ionic bond will have a covalent character. It will become a covalent character. So this ability of the ability of cation to deform or polarize the electron cloud is called polarizing power. Okay, so if polarizability can be represented as Pz, polarizing power is represented by Pp. Just a short notation for our understanding. Now think about this. Okay, so we'll move further into this concept. Can I just make some boxes here for you to get this idea? So polarizability is directly proportional to larger the size of anion, polarizability will be greater, is directly proportional to the size of the anion. Now why is it that like that? Now a simple everyday analogy would be, say suppose a nucleus is here, okay, and you have, suppose I am here and if my mobile is very near to me, can a thief steal it? No. Suppose I am here and mobile is further away from me, right? Which means a thief can easily steal it and run and go away. I will not be able to catch it. Simple. So polarizability is directly proportional to the size of the anion. Now again, polarizability is also directly proportional to high charge. Suppose more the number of mobiles I have, okay, easier for him to steal one of them and run away. Coming to polarization power is directly proportional, inversely proportional to size. So which means smaller the size, size, better the polarization. Polarization power is also directly proportional to the charge. Now apply this to lanthanides. Now you will take few minutes and apply this to lanthanides. See, suppose you have a mixture of lanthanides and your anion is being which it's a hydroxides, lanthanum hydroxides. इसमें tell me guys, क्या what is the anion here? Anion here is OH minus. Okay, specifically coming to this particular scenario, OH minus. In what is constant? OH is constant. What is here? It's a mixture of lanthanides, right? Mixture of lanthanides. Okay, so I think I had to adjust the screen here. Okay, so now think about this. OH minus is the anion here. So what are the differentiating factors? देखो भाई, this will not be the differentiating factor क्योंकि all the anion is same here, right? So anion is again high charge. High charge is only one minus one. हर स्टेप के लिए minus one ही है, तो ये भी नहीं होगा. Polarizing power is directly proportional to charge of the cation. देखो भाई, हर लैंथेनाइड का चार्ज क्या है इधर? +3 है. So again this will not be a differentiating factor. But what can be the differentiating factor is size. And just in the last video we have discussed that lanthanide contraction is the effective decrease in size as you go from left to right of the lanthanide series. So the size plays a vital role here in differentiating.